guys, welcome once more to another video in our YouTube channel. So in this video we are going to be talking about projectile motion, and here is our agenda. We are going to determine the time to reach maximum height of a projectile. Next, we determine the total time of flight. Next, we determine the horizontal distance traveled by the projectile. Next, we determine the maximum height itself reached. Fifthly, we determine the equation of path, and lastly we are going to solve a sample question from the littoral mock of last year. So let's get started. Alright, so we are going to consider a particle being projected. So we have our coordinate system x and y. It is projected from the point O. It follows a parabolic path. Now the speed of projection is u, as you can see on your diagram. But in projectile motion actually occurs in two directions, in the vertical direction and in the horizontal direction. So in the speed u makes an angle of theta with the horizontal. Now in the horizontal direction, the speed is actually u cos theta if you resolve, and in the vertical direction, the speed is u sin theta. Alright, so we have our three equations of motion. We have v equal to u plus at, that's equation 1. We have s equal to ut plus half at squared, equation 2. And lastly, we have v squared equal to u squared plus 2as, equation 3. So we are going to use these three equations to get all we want to get. So first, we are going to consider motion in the horizontal direction. We should note that in the horizontal direction, the acceleration is 0, and there's no acceleration in the horizontal direction. So let's first of all get the final velocity in the horizontal direction. So v of x, horizontal, I'm taking everything in terms of x, and vertical, I'll be taking things in terms of y. So horizontal direction, let's use this first equation. So we just replace v with v of x, we replace u with u of x, replace a with a of x, and we replace t with t of x. But we should know that the time taken in both directions, be it horizontal or vertical, is the same, so we just call it t. So we should know that in the horizontal direction, the acceleration is 0. There's no acceleration in the horizontal direction, and in the horizontal direction, our final velocity is equal to ux plus ax times t. Since a is 0, we just get our final velocity to be ux, right? But what is ux? Is the initial velocity in the horizontal direction, which is u cos theta. So the final velocity in the horizontal direction is u cos theta. Alright, now what about the final distance, or the distance traveled in the horizontal direction at any time t? We just do this, we replace it with x, but keeping in mind that there is no acceleration in the horizontal direction, and the initial speed in the horizontal direction is u cos theta, then t is the time of flight. So at any time t, the particle has covered in a horizontal distance of u cos theta times t. Now we look at motion in the vertical direction, but though we are also going to come back to motion in the horizontal direction when we are going to find the total distance traveled in the horizontal direction. That's the distance from O to A of the projectile. So considering motion in the vertical direction, we have our Vy to be equal to Uy plus Ay times t. But what is our Uy? It is the initial speed in the vertical direction, which is u sin theta. And what is Ay? Ay is negative g, because we are moving, the path of the particle is against gravity, so the acceleration becomes negative acceleration due to gravity. So our Vy becomes u sin theta minus gt, because our a is negative g. Now what about the maximum height, or the time to reach maximum height? We know that at maximum height, the vertical velocity is 0. So in my diagram, I'm going to indicate the maximum height. The horizontal velocity is v of x, which is our u cos theta, but our vertical velocity, that's vertical speed, is 0. That's the speed in the vertical direction is 0. So that is what happens at maximum height. So it means our Vy is 0, means that our u sin theta minus gt is equal to 0. So it means the time to reach maximum height is u sine theta over g. If we look for it, if we find that time in this equation, so the time here, t here, is actually the time to reach maximum height. Now what about the total time of flight? The total time of flight is simply 2 times the time to reach maximum height. The total time of flight is the time that the particle is going to move from point O right up to point A. But since we know the time is going to move from point O to the maximum height, we can just multiply that time by 2 to get the total time of flight. So our total time of flight is 2u sine theta divided by g. Next, we now find the horizontal distance OA. We call this the total horizontal distance OA. We call this total horizontal distance the range of the projectile. So our total horizontal distance OA is simply u cos theta times t. Remember that this is the horizontal distance, right, which is u cos theta times t. But now, since we have found the total time of flight, we can now get that total horizontal distance. So we replace t here with the total time of flight, meaning we get u cos theta times 2u sine theta divided by g. Simplifying, we get u squared times 2 sine theta cos theta divided by g. But 2 sine theta cos theta is an identity for sine 2 theta. So it means the range of the projectile is u squared sine 2 theta divided by g. The last but not the least, we can get the maximum height. Now we consider motion in the vertical direction using the second equation of motion. We have sy is equal to uyt plus half ayt squared. But our uy is u sine theta because it is the initial speed in the vertical direction. Our t we have our t is actually t max. We are going to see it later. And our a is negative g, then divided by 2t squared. Now since we are looking for the maximum height, then we are going to replace t here with the time to reach maximum height, which is u sine theta divided by g. So we replace u sine theta on g, we replace t with u sine theta on t, but of course we have to square it. So this simplifies to u squared sine theta on g, and this simplifies to u squared sine theta on 2g. When we do the difference, we get u squared sine theta on 2g, so it means our maximum height is u squared sine theta on 2g. And lastly, we are going to find the equation of path, or the equation of the trajectory of the particle. So we are going to use the third equation. Remember, we have used the first and the second, so we are going to use the third equation of motion in the vertical direction. So vy squared is equal to uy squared plus 2ay times sy. So we are going to replace our sy with y, call it the vertical distance traveled, and in the place of sx, we are going to replace it with x. We are going to see when sx is going to come into play. Alright, so our vy, we have it here, is u sine theta minus gt. We need to square it. We equate it to uy squared. Uy is simply the initial speed in the vertical direction, but we need to square it. Then minus 2g. Remember that our a is negative g, so we have minus 2g times y. When we square this left hand side and we simplify things, we arrive at negative 2u gt sine theta plus g squared t squared to be equal to negative 2gy. Remember that when we square this, we have u squared sine squared theta. It cancels automatically with u squared sine squared theta. So we simplify to get this. Now we can divide all through by g. Your g cancels from here. One of the g cancels from here, and the g cancels from here. We get this. Now we can divide all through by negative 2. Negative 2 cancels from here. We are left with ut sine theta, and then we divide this by negative 2. But we need the equation of path, meaning we need to relate x with y. So we need to eliminate t. So we need to find t in terms of x. So we come to this, our equation. This s of x here, we just replace it with x, and we call the x the horizontal distance traveled. So our x is equal to u cos theta times t. It means our t is x divided by u cos theta. That's why I replace t here with x divided by u cos theta, and I replace t here with x divided by u cos theta. I simplify and I get this as my equation of path. Y equal to x tan theta minus gx squared on 2u squared sine squared theta. So for the first part, we considered motion in both directions, in the vertical and in the horizontal. We have gotten the speed, that's the velocity, the speed in the horizontal direction, the range of the particle, the maximum height, the time to reach maximum height, the total time of flight, and finally the equation of path. Now the last but not the least of today, we are supposed to solve the littoral regional mock of 2022, the equation that came on projectile. So the equation reads: a particle P is projected from point O on a horizontal plane with speed u at an angle of alpha to the horizontal. Show that the time taken for P to attain its maximum height is u sine theta on g. B. The horizontal distance covered by P when it attains its maximum height is given by u squared sine 2 alpha on 2g. Given also that P takes 2 seconds to attain its maximum height and that it is at a distance of 40 rotary meters from O at this instant. Show further that the angle of projection is 30 degrees and the initial speed is 40 meters per second, and show that rotary x minus x squared on 240 is the Cartesian equation of the trajectory of the particle. Alright, so for this problem, I'm just going to display what is happening. We have our projectile, which is projected from point O with speed u. We have the vertical, the angle that the speed makes with the horizontal is alpha. Remember, motion occurs in two directions, so the vertical component of the speed is u cos alpha, and the horizontal component is u cos alpha, and the vertical component is u sine alpha. Now in the previous slides, we have already proven the time to reach maximum height as u sine alpha on g, so you just need to review and we are done with part A. Now we know that the horizontal distance traveled as the range of the particle is simply u squared sine 2 alpha on g, but we are supposed to prove that the horizontal distance covered by P when it attains the maximum height is u squared sine 2 alpha on g. So I'm just going to call the point that horizontal distance, that's the point A1, and the horizontal distance is OA1. So the horizontal distance when the particle attains the maximum height is the distance from O to A1, and we know that actually the distance from O to A1 is simply half of the distance from O to A. So we perform the same gymnastics we did in the previous explanations, but now since we are finding the distance from O to A1, that's the horizontal distance traveled when it attains the maximum height, we just need to divide the range of the projectile by 2 and we get the proof directly. Now the second part of the equation, they have given us that horizontal distance after 2 seconds actually. So after 2 seconds it attains its maximum height, and it is at a distance of 40 rotary from the origin. So after 2 seconds it is at the maximum height and it is at a distance of 40 rotary from the origin, means that's the horizontal distance. So OA1 is actually 40 rotary, but what is OA1? It is u squared sine 2 alpha on 2g, where we have been given g as 10 meters per second squared. So we can cross multiply and we get the first equation as 800 rotary to be u squared sine 2 alpha. Now we are also given that it takes 2 seconds to attain its maximum height, meaning the time to attain maximum height is 2 seconds. So T max is equal to 2 seconds. Now what is T max? It is u sine alpha on g, but g is 10. So we cross multiply, we get equation 2 as 20 to be u sine alpha. Now we can rewrite equation 1 as I'm going to rewrite u squared sine 2 alpha as u sine alpha times 2u cos alpha. I just replaced sine 2 alpha with 2 sine alpha cos alpha, and I wrote u squared as u times u. Now why am I doing so? I'm doing so because I can get u sine alpha from equation 2. I replace u sine alpha with 20 and then I get this. I can simplify and then I get 20 root 3 to be equal to u cos alpha. I call this equation 3. Now I need to eliminate u and alpha, so I'm going to use equation 2 and equation 3. If I take equation 2 and equation 3, I'm going to get 20 on 20 root 3 will give me 1 on root 3. U sine alpha on u cos alpha will give me tan alpha. I take tan inverse on both sides, I get alpha to be 30 degrees as required. Next, I can call this equation 4, and then I substitute equation 4 in equation 1. From equation 1, my u is equal to 20 divided by sine alpha, but alpha is 30, so it is 20 on sine 30. Sine 30 is half, so 20 on half is 40. meters per second as required. So we have completed the C part of the equation. Now the last part of the equation is asking us to prove that the equation of trajectory of the particle P is given by root 3 on 3x minus x squared on 240. So first thing to do is that I write the equation of trajectory. I now convert sine squared alpha to 1 plus tan squared alpha. Now from equation 3, that's from here, we have that our tan alpha is 1 on root 3. So it means that my y equal to x times tan alpha, which is 1 on root 3, minus my g is 10 x squared on 2 times my u is 40. I need to square it into 1 plus tan squared alpha 1 on root 3 all squared. We simplify to get 1 on root 3 is root 3 on 3 multiply with x, minus 10 on 2 is 5 x squared divided by 40 squared into 1 plus 1/3. 1 plus 1/3 is 4 on 3, and then 40 squared is the same as 40 times 40. So 5 takes 5 and 1 of the 40s, you get 8, and then 4 and 1 of the 40s, you get 10, and then you need to multiply by 3. So at the end, we have proven that the equation of our particle is root 3 on 3x minus x squared on 240. So guys, this is the first part of projectile motion. In the other videos, we are going to concentrate on solving just tutorial questions, since the basic concepts have already been explained.